Thank you, Dean Jackson, for those introductory words of the conference. I thought the message that you gave, that if we're really going to make lasting change, or changes that are really going to make a difference in education, it's coming together of people in education, natural science, and engineering really to try to make a difference, because the problems we face today really does take that collaboration. So that message you gave, I think, is really important. And with that, now it's my privilege to introduce our guest speaker, Yasemin, I gotta get this right, there we go. Yasemin Copur Gencturk, who is the Katzman Ernest Chair in Educational Entrepreneurship, Technology and Innovation, and a Professor of Education at the University of Southern California. Yasemin is one of the leading voices in education with respect to mathematics education and AI. It was really interesting for me. I met Yasemin last year at ARA, not just this one, but last year. And it was really interesting for me, like 3 years ago, there was like a handful of talks on AI in education. Last year there was more, and this year it seems like half the talks were on AI in education. So it's really my honor to have Yasemin come and speak to us about her work and what she's done to really use AI in a productive manner to really foster kids' understanding in math education. So thank you for coming from sunny California to chilly Michigan. We really appreciate it. So,
thank you. Okay, I have too much. Is this one working? This one's working, right?
oh, I don't know which one you need to use. We're good.
I think I'm gonna use this one. How are you? Good.
Wonderful.
Okay, perfect. I'm gonna move around, but I know that I'm gonna stay in this place more often than the others. I'm so excited to be here, be back again. I was here a couple months ago, had another talk focusing on my other work, other line of work. But today I'm gonna talk about AI in education, particularly my work around in mathematics education. I'm really excited to be here. I'm saying sincerely, I learned a lot. You guys are doing such a cool work. It's amazing. It's very innovative, and at the same time, it has important implication for teaching and learning. So thank you for doing that. Okay. I don't need to come here. Okay. So when I was preparing my presentation, as I do for any presentation, I always look at the places that invite me to get to know the people a little bit more. So I checked the Create Institute, and you guys have 3 major goals, which I love it. Innovation, right? You want to use different novel research methods, novel ideas to develop meaningful products. And I love the fact that you place a lot of emphasis on research, which is something I really care about. So you do research to refine your products, your ideas, and to improve teaching and learning further. And I also like that your 3rd goal of dissemination, which is something really important. At the end of the day, if we are not sharing what we learn from research, right, we are not making an impact that we need to make. So that made me very happy that my goals for my own research perfectly align with the Create Institute. So, I'm a math educator. I'm not an expert in AI. So everything that I'm going to talk about from a perspective of a content expert. But I have amazing scholars, JT from MSU, and these 2 bright students who work closely with me. So everything that I'm going to say is more about my view of how things should be. Okay, so since ChatGPT, right, I woke up every day with another AI tool out there, solving problems that we needed to be solved, right? And the variation in terms of the solutions they offer is getting increased and increased. So we are seeing now that there are so many products for so many things, right? But there's a group of people who are really concerned about what is going on with integration of AI in education or in general. And they are right, because there are some security issues when it comes to the using AI, right? Data security. And we know that if AI is not used responsibly, it's lowering the cognitive demand of users, right? This is a problem. And cheating is increasing. That's another problem. And also we know that AI tools are inherently biased if it's not trained carefully. And finally, there is a lot of impact on natural resources when we use AI. So there are pros and there are cons. Why am I saying this? Because in this talk, I'm going to revisit these three features. When we are using AI in our education, in our research, we should pay attention to. We should use AI responsibly, and we should use successfully. What does that mean? It means that it has to be designed, any product, including AI, has to be designed with a purpose. I know it sounds trivial, but trust me, if you look at out there, many available tools are not designed to solve a significant problem, right? We have to be honest. They are there for solving very trivial problems of ours. We don't need to use our resources to solve these trivial problems. So it has to solve a problem that is meaningful. Something can start with a good intention, but when it's translated into a product, you will see a discrepancy between what is envisioned and what is actually achieved. So in addition to the purpose, it's always important to pay attention to the final product to see whether it's really designed to what is claimed to solve. And I love research. I love evidence. It's not only about whether something works or not, it informs further iterations, right? That's why research matters. And one thing that I love about research, I'm an educator, I have ideas, but I love research more. Meaning that I am okay changing my believed ideas if research is not supporting my ideas. I am okay with revising and understanding further. Okay. We haven't started my presentation yet. That was just it. So my presentation always starts with a brief introduction of myself, because we met with, I met with some of you before, but this is a great opportunity for me to get to know me a little bit. And you can see how I am approaching research and how I'm approaching the problems that I'm trying to solve, so that you know that I'm not crazy. I'm a normal human being. And I will use 3 showcases of how I use AI in education. One of them is that something I'm very proud, AI-based PD. Again, there are so many products out there, and I'm going to show you that one thing that stands out with our product, it creates an interactive learning opportunities for teachers where AI doesn't serve as the information teller. AI uses as a facilitator. Trust me, it's not easy. We spent years and years of research, so we were able to accomplish something, and I'm going to show you the results. And we are in the phase of another study to check whether it's still working. The second one, Yushan shared a little bit, but I'm going to talk about a little bit more. How we can use AI in coding. And spoiler alert, we are using in a way that we are not simply checking, oh, did they say this? Did they say that? No, we want to check whether AI can understand what we want experts to understand by looking at the overall text and can make sense of the level of understanding. It's been a crazy, challenging experience for us to deal with this research, but finally we are getting some good results, and we are doing it literally for free. We have 0 funding to do this work. So I'm truly grateful for my colleague JT and his students for working on this for free. Okay, the third one, this is new, baby, but I just want to show you how we are designing a tool for providing feedback to students on their math homework. And hopefully I will open the floor for Q&A. I'm looking forward to hear what you're going to say. Okay, who am I? I'm a person who loves math so much. I was born and raised in Turkey, and my when I was a kid, math was my favorite subject. I had no idea why I loved it so much, but I loved it from day one. I have so many crazy stories about, me. In Turkey, we wear uniforms. So when I was a kid, I have an older sister, and we were sharing a wall between the schools. So anyway, even I was at the age of going to school, I used to wear my older sister's uniform and sneak to school so that I can start schooling. But I wasn't allowed. So anyway, if you ask my older sister, she thinks that I was the embarrassment point for her throughout her life because I literally followed her everywhere, and she was 5 years older than me. And I was trying to hang out with her friends. So anyway, very enjoyable moment of my life, but apparently very traumatic for my sister. So I love my math. I got my degree in mathematics. So I consider myself as a content expert and someone who really love math. So I came here to United States with a scholarship. I got my degree, 2 master's degrees. One in statistics, one in education. So those of you who attended my talk a couple months ago know that, I never taken education courses before coming to the United States. I never knew that people do research to improve the quality of others' lives. I know it sounds so naive, but that's really impacted me. That's one of the reasons that I love doing research, because it gives me a special power to change something that bothered me throughout my life. Okay, so I came to the United States. I was a research assistant for a master's degree designed for K-8 teachers to improve their knowledge in math and science. I was supposed to find a classroom observation tool that can be used both for capturing the quality of instruction in math and capturing the quality of instruction in science. Remember, I'm learning education, but my background in math. So I was looking at all the existing tools, and one thing that I was noticing, the checklist. Is teacher using direct instruction? Is the lesson around student-centered learning? So we ended up with one of the tools that can be used for both math and science, and I'm sitting in the classroom using the rubric, right, the classroom observation tool. And based on the score that I'm assigning to the teacher, based on the rubric, teacher is supposed to be doing a good job, right? The scores are high, but it's bothering me in math because I know that the teacher is not doing a good job, but the rubric is not capturing, okay? Because rubric focusing on actions by forgetting something. This is the reason, why whole my dissertation idea came from. What I notice is that sometimes we focus so much on the actions, we miss the important part, right? Teaching and learning mathematics, teaching and learning science. What I mean by that, I felt like the content became secondary every time when we talk about how we can improve student learning of mathematics, how we can improve students' quality of math teaching. Does it make sense? I hope so, because right now the whole discussion, you guys know that science of math movement and things like that, if you see that it's all around, we have to teach this way, we have to teach that way. Okay, I wish life is that simple, because teaching is very complex, right? Teaching is dealing with 20, 25, 30 students all at once, right? Making sure that they are learning the content you want them to learn. Making sure that they develop the skills they need to be successful. It means that whatever the skills and content you are helping them to learn should be the top priority, rather than how you are doing it. Because we say that most of the time, right? Teaching requires listening, responding, right? It's hard to capture the quality of teaching, focusing on actions. That was my argument when I was a PhD student. You have to pay more attention to what is going on mathematically. Is teacher paying attention to the math in student responses? Is teacher ending the lesson with making sure that kids understand the key mathematical ideas at the end of the class? So, and then it started like this, based on my observations. And I was thinking, okay, then what does that mean? It means that teachers should have specific skills that are needed to be effective teachers. So I got funding from thanks to Institute of Education Sciences, NSF, to identify and measure these proficiencies. You know, the elements of expertise mathematics teachers needed to be successful. And that was the first line of my research. Okay, understanding the nature of the expertise, content-specific expertise needed for teaching mathematics is just one side of the story. Then, creating opportunities, developing professional learning for teachers to develop these skills, oh my God, it's another story. So that created my second line of work. And like the dean said, we always have to make sure that, right, whatever we are doing, it's improving all of our students, right, learning opportunities. So equity is always important. So my third line of work, how we can remove the barriers in the classrooms so that each and every student can learn mathematics. Okay. So I know it's been a while. Let's go back to what I mean by these three elements, right? We said that it has to be designed with a purpose. And we have to measure, we have to make sure that whatever the product, the outcome, really is designed to whatever they say they are designed to do, and we have to see some evidence. To make my point, I always start with a counter example. I hope you guys don't love Camingo so much. Do you know the Camingo? No? Okay. Because, okay. Raise your hand. Okay, okay, thank you. Sorry?
You shut it down.
Oh, really?
Yeah.
When?
Months ago.
Okay, perfect. I'm glad. Finally, something good happened. Yay! Okay, and I'm glad that I'm using the video recordings from a couple months ago. Okay, I'm really happy. So, let's see what they say. Free AI-powered tools designed to save you time and improve instruction, right? So I can skip this part if we get rid of Camingo, but I'm sure something similar will come up. So remember, this tool claims that it does two things. Save time, improve instruction. Okay, so I look at the lesson plan, and I ask it, Camingo, to create a lesson plan on ratios and proportional relationship. Pay attention to the lesson plan it creates. Okay, it's done. It created. Did it save? Oh, almost now. Did it save time? It did, right? Okay. So then we need to look at the improve instruction part. Do you notice anything about the lesson plan it created? Remember, the goal is to help kids learn ratios. So, have you noticed anything? Sorry?
Did it have any problems?
Yeah, this is the problems that kind. Yeah, it doesn't have open-ended problems that promote. That's one thing. But one thing that really bothers me.
Graphics? Anything to interact?
Yeah, yeah, there is not like that. But I want you to look. These are all good points. Yes. In addition to those, something really bothers me. Numbers are relatively primes, okay? So you might be thinking, so what? So what that numbers are relatively prime? I think it's a big issue. Why? The main idea behind ratios is multiplicative reasoning. You guys can disagree with me, right? I would be so specific about the numbers that I choose to teach, ratios and proportional relationship, because equivalent ratios are created by scaling up or scaling down, right? Having a common factor between the two values, two numbers, is a good teaching moment for teachers to help them understand the unit rate and help them understand the multiplicative invariance between the quantities. Then you have to select your numbers carefully. And trust me, there is research out there showing that numbers used to teach a concept matter a lot. Okay. You see, 15 to 11, right? The example, for example, show how to express ratio, 15 to 11. Two big relatively prime numbers. Is it going to help kids to learn the idea, the multiplicative invariance? I disagree. So, since we don't have Camingo anymore, what I did, and I'm going to skip this one while you guys are watching, I'm going to go fast. So I pointed out and I said, hey, Camingo, the numbers you selected are not good to teach the gist of the math kids need to learn from ratios. And then when I pointed out, Camingo only changed the parts that I highlighted. Then I had issues with that. First, you said that it's going to improve instruction, but I need to figure out the issues with your lesson plan. So I need to have the expertise to figure out what is wrong with the resource you provide for me. Second, you are not fixing everything. You are only fixing the parts that I pointed out. Okay, it goes back to what I said about the improving teaching and learning. First of all, you are not designed to do that. Second of all, only teachers with the expertise can identify these issues and fix it before using in classrooms. But we know that kids who need support the most are taught by teachers who have the least expertise. Do you see where I'm going with this? So using this type of tool creates more opportunity gap between students who need more support versus between students who don't need the support.
You know,
Okay.
it's interesting though, Yasemin, the lesson plan uses all the right buzzwords. It has wrap up, it has project-based learning in it. It's couched, it knows what it's doing, but it doesn't.
Excellent point. So most of the time, that's exactly what I noticed with large language models. They know how to use buzzwords. They create something, and if you don't have the expertise, you might feel like, oh, this is good. But if you start paying attention to the content of it, and you will identify so many issues with the content of these products. Okay. I'm not gonna spend so much of time on this, but that's my, making my point clear. I got a question from 2003 TIMSS, and it's a ratio problem, right? I'm proving you that this is a problem. So, missing value type of problem, it's just finding the missing value for the equivalent ratio. Do you want to solve the problem? Do you want to skip it? How confident are you with your ratio knowledge? Okay. Let me make you sweat a little bit. Do the work. So, I'm not going to ask you to solve it. I'm going to ask you, okay, this is so TIMSS 2003 asked to 8th graders. Now I want you to think about what percentage of 8th graders do you think answered that question correctly?
In 2003.
2003.
40.
Okay. Joe said 40. Are you guys not? Come on. I have so many slides that I need to cover. Oh, 5. Okay, good. 8. I'm sure we have more than 8, 9. Come on, there is no right and wrong. You guys just estimating. 19, very good. Okay. 24, 26, 27. I'm proud of you guys. Okay. And I'm curious about the results. So what do you think, what percentage of students think answer the problem correctly? and they start learning. Even in 2003, I think they were starting learning the ratios in 6th grade. So. Okay, we are done. I'm giving you a last chance for you to enter your number. Come on. Yeah, that's why my students don't like me. I never give up on them. Okay, no more response? You are tired of me? Yes, yes, Lord. When will this end? She is so annoying. Okay, let's see. Oh, okay. So, 50, 25, 72, 1%. Okay, someone is very pessimistic. Come on. Come on, people. Have faith in our education. Okay, 45. Are you ready? Are you ready? Moment of truth. Okay. Okay. Half of the 8th graders in the United States, almost. So 50% and 45 are almost similar in their prediction. Answer this question correctly. Okay. This is from middle school math teachers. A study I done. So I asked teachers to solve a ratio problem. A little bit different from the problems they see in a textbook. What are you noticing? Percentages very similar. You notice that? Okay. That's what I'm trying to say. We have to go beyond. Are they using this? Are they using that? We really need to, at least. That's what I strongly believe in, that we have to help them understand the content they teach. We have to help them understand how to teach the content more effectively. Okay? So, that was my motivation. I knew that there is a room for teachers to enhance their content and pedagogical content knowledge of mathematics. They need to develop these, they need more opportunities to develop these proficiencies. That's my goal. And that's where the AI come in. Yusheng and Hang know that I use AI with always starting with the experts. I don't want to put AI in the chair of an expert. They can help us, but I don't want them to do the heavy lifting for us. So we start everything with understanding what is going on, what are the areas teachers need to help, and then we do the heavy lifting in terms of designing the content. And last time when I presented this, I didn't know that people were saying that, yeah, why don't you use AI to create the activities? We did try. AI sucks. If you let AI to do on its own, AI sucks. That's what I want you to understand from this presentation. If you want to create good quality work, AI can be your aid. But AI cannot drive. AI cannot be in the driver's seat, okay? That's why, when people are so scared of, will AI replace us? Oh God. If it is gonna replace us, we are doomed. The future is so dark for us. Not because, it's gonna replace us, because it doesn't have the capacity to do the richness of the thinking that we can bring to the table. Okay, so what we did, we designed something very research-based. We not only look at what kind of knowledge and skills kids are struggling, we also look at the research and we identify what are the areas that teachers need more support. And then we created activities specifically designed for teachers, and we set goals for each activity, and then we created scaffolding opportunities. We call it HINT. If teachers need support, what kind of support we can provide. And then we get feedback. You guys know this, you are I check your presentation, so you know how it works. We get feedback from teachers, improve it further and further. Okay. So how we bring this idea to life? So as I said earlier, we created activities, we set the expectations, we created scaffolding opportunities depending on how much support teachers need. So we created 3 different levels of hints. One is the first one, more conceptual, right? Our logic was that if teachers are very close to achieving the learning goal, we can start with just a little bit conceptual push. But if they need further help, we come up with a hands-on activity that is cognitively less challenging of the main activity they solve. And if they still struggle, we give more concrete and direct learning activity or the question for them to think. So these are some of the tools that we created. And every activity ends with the key ideas. We want them to after they completed this learning experience, we want to say that these are the ideas that you learn very explicitly, so that they can see, they can see more meaning behind the activity they just completed. We also use AI in analyzing teachers' responses to see which expectations, learning goals have been met every single time when they answer the questions given by the AI, okay? So they start with the activity. Let's say if the activity has 5 expectations, right, this interaction continues until teacher meets every of these 5 expectations have been met. And again, depending on the teacher's level of understanding, it might take 2 rounds. If teachers need more support, it might take 5 rounds, 6 rounds, okay? So in order to make sure that the system backend works well, we created different agents. You heard, today in the presentations to multi-agent framework. So one thing that, I'm sure you noticed that if you put all responsibilities on one large language model, good luck with that. It doesn't remember all the responsibilities. Again, it's not like human. So we created 4 agents. Filter is responsible from making sure that whatever response the teacher provides is relevant to the question being asked. And Judge AI was responsible for evaluating teacher responses and determining which expectations have been met. Responder was responsible rephrasing what the teacher said and then asking hints or prompts if teachers need more support. And remember, if teachers are not, no, I didn't say this one before, so remember doesn't make sense. So facilitator, steps in if, multiple interaction teachers are still struggling with understanding the concept. Facilitator comes in and explains the concept, because we don't want to create a frustration for, point for teachers to say that, okay, this never ends. I don't know what I'm doing. So we jump in and say, this is what you are learning. Okay, so this is a walking example. You log in the system, you answer a question, filter checks. If your response is not related to the question being asked, then you'll be asked you'll be prompted to answer the question. If your answer is relevant, Judge evaluates which expectations have been met. And if you meet all the expectations in one attempt, perfect. You will move on to next activity. If you haven't, then you will get feedback and get another question or another activity, and then you'll have a new response. And when you have a new response, the process starts. And if this loop continues 3 times without meeting any expectations, the facilitator comes in and says, okay, let me summarize what you are learning. How I am doing with time?
Good.
Good? Okay.
About 15 minutes.
Oh, okay. How are you guys doing? Are you happy?
Yes.
Are you going to invite me again? Okay, promise, deal. Okay. Next year, I'll be... Joe, no, Okay. Joe, I love you. Okay. So, this is the part that, I'm going to skip quickly, unfortunately. I want to brag about my findings, but I never have time to do that. I am so proud of this. You know why? We did this study during the COVID. My colleagues were thinking that I was crazy. I was saying that we will be able to do that. I'm sure we can do that. So I love my students. I know that they are dealing a crazy person, but they never give up, and they continue to work. So we did randomized control trial, okay? And in our randomized control trial, we wanted to see the impact on teachers' knowledge, instruction, and student learning. You guys are familiar with PD studies, right? How many PD studies do you know that shows effectiveness at the student level? Not many, right? Yeah, okay. This is one of them. And we ended up with what were clearinghouse. That's why I'm so proud. Okay, this is showing that the PD improves teacher knowledge. Yeah, we all know that. There are so many studies out there showing that if you design a PD, your teachers are the target population. Of course, you will see some changes. We know that it's hard to see changes in practices, and we did not share learning materials with teachers. The program is designed to improve their understanding. We never provided resources for them to use in the classroom. I'm not saying this to say that, oh, this is a good way of doing it. No, we didn't. We didn't have the time and the resources to do that. Our goal was only to help them improve their understanding, both content and pedagogical content knowledge. And I was shocked, to be honest. I saw that the quality of the math instruction has changed based on the activities they use and the cognitive demand and more the coherent instruction for promoting student learning. This is one of the problems that teachers in our study were using. I mean, I don't need to comment on that. It's very problematic, right? It's not hitting any of the key skills that kids need to develop. And this is another teacher from the treatment group. Again, he or she found this activity we didn't provide. And this is not one of the activities we use in our system. She found it. It's rich. It hits very important ideas in math. And more importantly, it detects students who use additive thinking, right? So it's very strategic using these type of activities because it shows that teachers not only have the knowledge of how to select mathematically rich activities that can promote student learning, also the teacher improved their understanding of how to select an activity that could reveal the struggles we know students could exhibit. You might be thinking, why do you care? Because if you detect, right, the struggle early, you can address it and you can improve it. Most of the time what we do, we'll wait till the end and say, oh, they didn't learn. But this way of doing it allows you to early detect struggles and respond it. Okay. This is another miracle that we have found. Students whose teacher completed the program learn statistically significantly higher than those whose teacher did not complete the program. And the difference was almost 1/4 of the grade performance level. So we were happy to see that, and we designed with a goal, and we were able to maintain the goal during the product development, and we were able to provide evidence. So this is the final version of it, and right now we are literally, as of yesterday, we started doing our second randomized control trial to see whether this program has an impact on pre-service teachers' knowledge and instruction. Hopefully we will see some positive findings. We don't know it yet. We don't know it. Okay. One other thing that we added to this version of the system, we had thumbs up and thumbs down menu because we want to make sure that we are creating a constant loop of improvement to the system. So if teachers think that the system is not recognizing their answers or the feedback they receive from the system is not good enough, they will be able to give feedback, and we will use that feedback to improve the system further. So when teachers are completing the activities, they won't be able to see that, but here we just make it, you can see the filter agent, judge agent. So this is a screenshot of you to see that how the system works in the background. Okay, perfect. So the next example, AI-based coding. So I'm interested in content and pedagogical content knowledge of math. So when I'm very much interested in not only identifying the skills, but also measuring it. With content knowledge, multiple choice items can work to some extent. But if you look at the pedagogical content knowledge, there is no successful effort out there across the scholars finding a way to use multiple choice items to measure pedagogical content knowledge effectively. It's it's a failed attempt. So many people have tried. So many scholars have tried. It's not working. There are so many reasons behind it, but at the end of the day, it's not working. So what does that mean? Scholars who are using open-ended items are more successful. Yeah, but when you start using open-ended items, what happens? You need to train, right? You need human coders, right? So I had human coders. I trained my PhD student. We coded the data from hundreds of teachers, months of work. Perfect. So we did for the pilot study, and he graduated before. I'm happy for him, but before we start coding the nationwide sample, the data we collected from a nationwide sample. So I have over 1,000 responses per item, and my trained student is gone. He has a job. He doesn't have a time. So what do I need to do? I need to train another student, and that student will graduate too. So never-ending cycle, right? So what I was thinking, how can we find a solution to that, right? So, and I want you to take a look at this problem, because I'm going to show you two sample responses to this one. Okay. This is a question for knowledge of math teaching, because I asked teachers to use two different representations, the commonly used ones. And what I want them to do, connect the math idea in both representations so that students understand. Okay, this is, the coding requires someone who understand the content, okay, and understand the pedagogy. So trust me, training takes time. Training human coders takes time. And this is a response from a teacher. Okay, did you read it? Okay, and I'm gonna show another one. Okay. To me, the way that I conceptualize knowledge needed for teaching, this response is better than this response. Okay, why? Because remember, I always want to go back to the same area. I want to make sure that whatever happening in the classrooms, kids are leaving the classroom with a clear understanding of the content and skills we set for that lesson. It's very important for them to understand the values change, but the unit rate, constant of proportionality is the same, right? For equivalent situations or proportional relationship. This one, it's very generic, right? So I want to make sure that if I'm using AI will not only look for the keywords and make sense of these responses holistically and say that, hey, this is a better response than this one, okay? Good luck with that. That's not easy. So what we have created, there are different iterations. I'm sharing the results from the one we finally published. You know education research, so we work with the computer science colleagues from computer science, JT and his students. They publish. We still publish the first iteration of the system. That's why I'm going to show the results from this one. So how does it work? And you can cover it a little bit. But what we did, remember, I train human. I have the coding manual, right? And when we do the human training, what we do, we first give them the coding manual, right? We code the data together, and when we have discrepancies, what we do, we discuss, we come up with a shared understanding. When it's needed, sometimes we add some clarification points so that when we code separately, right, we can code the data the same way that, reliably. Are we clear? Have you ever coded data? I know some of you did it. Okay, very good. So, we try out the same thing with the machine. But again, we use multi-agent because I think you got the gist of it. Single agent doesn't work well. So we gave the guidelines, coding manual, and training data to the first agent. We call it grader. Grader codes, and then the second agent comes in and look at the discrepancies between human-coded data, right, sample training data, and the AI's codes, and say, oh, okay, you are struggling with this and that. And pushes the data to what was refiner, right? Refiner then analyzes and says, oh, these are the clarification points needed so that the first agent can understand the data carefully. Did I do a good job, Yushan? Yes, okay. So that's the gist of it. I'm not gonna bore you with details, so many things going on. If you wanna learn more about it, we just publish it, so we will talk about it. So to test whether this works really effectively, what we did, we already data coded, remember my PhD student, from 268 teachers. We used 11 open-ended items, 2 from content knowledge, 9 from pedagogical content knowledge. And we wanted to see that whether the AI's efficiency changes by the type of pedagogical content knowledge. Only 5 minutes left? I knew it. Okay. I knew that I was going to scrap at some point, but I didn't know that it was going to be that quick. Okay. So what we are seeing is that these are weighted kappas. This is the human agreement. This is the method that we are using. So it's not that bad, right? And if you look at this, so this is overall content knowledge, overall pedagogical content knowledge. And if you look at it for the 3 dimensions of pedagogical content knowledge, you will see that PCK items are tough, right, for AI. But Grade OPT is the multi-agent framework that we are using. So it's not doing bad, okay? And because I have only 5 minutes left, if you want to learn more about it, here is the open access publication. Okay, the last example from the feedback, and all I'm gonna say is that when you look at the feedback literature, they say that effective feedback needs to be guided by these 3 questions. What is your goal, right? What is the goal for students expected to attain? How much progress they made, and what actions they need to achieve the gap, okay? So we translated into the 3 areas: strengths, weaknesses, and suggestions for improvement, meaning that we conceptualize for feedback to be effective, they need to tell students what they are doing right. They need to tell students what areas they still need improvement. They also need to provide some guidance to overcome their weaknesses, okay? In addition to that, when we were doing the literature search, we have identified that not only content of the feedback matters, but also tone and the style of the feedback. So we added these features, and these are the different content focus that we offer to the users. We have not been able to test out so far what we are doing, so stay tuned. Should I show the video? Not sure. So, you wanna? How much time do I have?
4 minutes.
Okay.
Hey everyone, and welcome to my demo. We're going to show
Can you hear it?
the feedback generation system.
No.
Okay.
First, we start by personalizing the
That's okay. I'm gonna skip this one. Hopefully, you will see more, because I want to make sure that these points are clear. So we need to make sure that research, particularly around teaching and learning, plays a good role in the tools that we use AI. And also, yeah, this is my second point. And also, we really need to pay attention to the tools that we are developing, also tools that we are encouraging teachers to use in their teaching or for students to use for their learning. What are we trying to accomplish? This is really important. And also, the same point, you guys are doing using AI responsibly, but unfortunately there are so many tools out there teachers, students are using, have no research involved in terms of checking their effectiveness, or they use outdated the research around the effective teaching and learning, so we have to be cautious. And that's end my presentation. So thank you so much for listening.
Great, so now we've got about 5 to 10 minutes worth of time for questioning. What questions do you have for Yasemin?
Yeah.
Oh, go ahead.
So thank you so much for your talk. I had a question about the AI model that you were developing for teachers to improve the style of how they deliver the data. But I was wondering if you were also working on something for students, because we all know students use ChatGPT all the time with their homework. So might as well have something that we know is effective to help with their learning rather than just give them the answer. And it's kind of working both hand in hand from the student side and the teacher side. So.
An excellent question. Unfortunately, we never work on the student side. So it's all related to the research and funding that we don't have. So we have zero funding to do the work around the implication for students. But you guys have it. So there are some other work that is going on, using creating tools for students. Yeah, excellent question.
Other questions? What other questions we have?
Thank you for asking me. Excellent presentation.
I have a question for you, Leo.
A lot more than London last time. Excellent facial expression management. So she asked me to check on that when I was.
But you have to give them a little bit background,
Okay.
right?
Yeah, because last year I went to a conference in London, and she also happened to be the keynote speaker, and I was a photographer in that conference. And she said she was very worried about her facial expression management skills, so she asked me to watch on it this time. Very happy to report that she did a fantastic job.
Okay, perfect.
Now on to the actual question.
Okay.
I wonder if you could explain a little bit more about the learning mechanisms theory of increased pedagogical content knowledge and content knowledge of student learning. Because so far you've made a strong claim about everything you're doing is to increase student teacher PCK and CK, and you've said you've provided evidence that this could influence student learning. Can you elaborate on the specific mechanism of how does this include student learning, and what are the policy or pre-service teacher training implications? Thank you.
Okay, perfect. Excellent question. So before I answer your question, you need to answer my question. Was my presentation different from the one in the... Okay, exactly. Thank you. Okay, so one thing that I want to make sure that my biggest fear is that when I give a talk, right, there will be always, the attendees from the other talk, and I don't want to bore any people to death. So my rule of thumb, every time when I present something, it has to be significantly different from the another presentation that I made. So it puts a lot of pressure on me. When Leo saw me today, he said that, hey, I hope your presentation is different from the one you made in November. Okay, so I made it, yay. Okay, so now I forgot your question, just kidding, I remember. So in terms of the domains of the teacher knowledge, it all based on the research that we have identified what are the core skills, right? So this is not only my research, it's also based on the research not from math education, also science education. You guys are doing very cool research, by the way, so it inspires me a lot. So this is how I define the domains or the distinct subdomains of content knowledge. Actually, for pedagogical content knowledge, I draw on the research in other domains. But for content knowledge, it's more about the research around knowledge and skills not only teachers need, but also students need to be mathematically proficient. So, like the NRC's chapter 4, unfortunately know to by heart every word. So this was the guiding principles of the components. When it comes to the learning, right, again, it's not only driven by theories, it's also driven by research. So I love theories about teacher learning. You might not like what I'm gonna say this, but I also believe that research, some of the theories might need revisions. So I don't make my judgment only based on the existing theories of how people learn. I specifically look at research and identify effective opportunities research has identified in terms of improving teachers' knowledge and skills. So I try to do a combined effort. Theory-driven, but not completely based on a single theory, a combination of theory and empirical evidence in terms of how we can develop these knowledge and skills. But the main way of we focus on is that teachers need to build knowledge actively. So that's why instead of AI is used as the information deliverer, teachers will construct their knowledge by engaging those activities. Excellent question.
So we have time for one more question before we move on to the next part. I think we have a question back there.
Professor, thank you for your presentation. First of all, the presentation itself, it's a very high bar to step on.
Thank you. I appreciate it. Yeah.
You addressed the intersection, that part that lives between content knowledge and pedagogical knowledge. Okay, going back to Schulman. There's an adaptation.
Can I use my natural voice? It's easier.
For some, yeah, I think they are interacting.
Yeah, it comes with them. You have enough preparation, you can whatever.
Here, if they're recording, excuse my.
Oh, okay.
For accessibility purposes.
So there's an advanced or an evolution of that model it calls TPAC, okay, which brings in technology by Collar Mishra. And I was wondering, since the topic you started with, AI, is so ill-defined, both in the way that what AI is and how it functions and how it helps us and how the teachers interact with it. What do you see in that sort of the middle of the Venn diagram between content, pedagogy, and technology in terms of AI?
Okay, excellent question. So I think, yeah, I'm noticing that, I started with CK and PCK. Now I'm realizing that I definitely need to include technology, and that's going to expand my research a little bit further. But excellent question. I think it matters more to capture teacher knowledge of technology content in teaching when we are trying to see how technology impacts student learning, but less likely for the AI-based PD that we are doing, because it's less relying on their knowledge of technology to interact, because our interaction level is very basic level now. Everybody knows how to respond to the AI questions. But you are absolutely right. I think technology becomes an important dimension of expertise needed for teaching any subject matter, because we have to accept the fact that now AI will be part of the teaching and learning. Yeah, excellent question.